Have you ever wondered about the mysterious world of quantum physics? Well, buckle up, because we're about to dive into it. Quantum physics, or quantum mechanics, is a branch of physics that challenges our understanding of the universe. Unlike classical physics, which deals with things we can see and touch, quantum physics delves into the realm of the extraordinarily tiny, like atoms and subatomic particles. One of the core concepts in quantum physics is the Heisenberg uncertainty principle. Named after physicist Werner Heisenberg, this principle is a cornerstone of quantum mechanics. It tells us something absolutely mind-boggling. We cannot know both the exact position and the exact velocity of a particle at the same time. The more precisely one of these is known, the less precisely the other can be known. The Heisenberg uncertainty principle is a fundamental part of the quantum world. But what does it really mean? Let's find out next. The Heisenberg uncertainty principle sounds complicated, doesn't it? But don't worry, we're here to simplify it for you. It's a fundamental concept in quantum physics that states the more precisely the position of a particle is determined, the less precisely its momentum can be known, and vice versa. But what does this mean? Imagine you're trying to watch a speedy hummingbird darting around in your garden. The quicker it moves, the harder it is to pinpoint its exact location at any given moment. Similarly, if you focus on its position, its speed becomes a blur. In the quantum world, this isn't just a limitation of our observation, but a fundamental characteristic of particles themselves. They don't have precise values of both position and momentum at the same time. So the more precisely we try to measure one quantity, the less precisely we can know the other. But how does this principle apply to electrons in an atom? Let's see. You've probably heard of the term orbitals in your chemistry class, but what are they really? Well, in the simplest terms, orbitals are regions around the nucleus of an atom where electrons are most likely to be found. They are not circular paths or orbits as depicted in the Bohr's model of the atom. Instead, they are more like clouds surrounding the nucleus. Now let's talk about quantum numbers. Each electron in an atom is described by 4 quantum numbers. The first 3, the principal, azimuthal, and magnetic quantum numbers, describe the electron's orbital, its size, shape, and orientation. The fourth, the spin quantum number, describes the direction of the electron's spin. These quantum numbers help us to understand the behavior of electrons within the atom. So, in a nutshell, orbitals are where electrons like to hang out in an atom. But did you know they come in different shapes? Let's explore that next. Just like how we humans come in different shapes and sizes, so do orbitals. Let's start with the simplest, the s orbital. Picture a sphere. That's your s orbital. It's like a cozy little bubble for an electron. Now the p orbital is a bit more complex. Imagine a dumbbell with 2 lobes on either side of a central point. That's your p orbital, offering a bit more space and a unique shape for the electron to move around in. And then we have the d orbitals. These are even more complex, with 4 of them looking like 4-leaf clovers, and the 5th one appearing as a dumbbell with a donut around the middle. Now, you might wonder why we're talking about shapes. Well, these shapes represent the electron cloud or the probability density. It's basically where the electron is most likely to be found within the atom. So, s, p, and d orbitals are just different homes for electrons in an atom. But what does this all mean for us? Let's wrap things up. Quantum physics might sound like a tough nut to crack, but you've just managed to understand some of its key concepts. Let's quickly recap. We started by diving into the Heisenberg uncertainty principle, which in simple terms tells us that we can't know both the position and momentum of a particle with absolute certainty. We then moved on to the concept of orbitals, regions around the nucleus where we're most likely to find an electron. We also touched upon quantum numbers that define the unique state of an electron in an atom. Lastly, we visualized the different shapes of orbitals. Remember how the s orbital is spherical, while the p and d orbitals are more complex, resembling dumbbells and clover leaves respectively. Thank you for watching the video. If you found it helpful, give us a thumbs up, share with your friends, and don't forget to subscribe to our channel Fax Academy 0122. Comment below with your thoughts or any questions you might have. Until next time, keep exploring the quantum world.